welcome. It's me, John Park, and it is a weird inside the studio instead of in my workshop edition of John Park's Workshop, the increasingly inaccurately named show. Today, there's some noise and things going on that prohibited me from doing the show from the workshop today, but hopefully we'll be able to take care of that and get back out there soon. First of all, thank you for everyone for stopping by. If you are interested in hanging out in the chat and seeing what people are saying and doing and suggesting things and warning me when my audio goes out and all those good things, I would recommend you check out Discord. In fact, that's what I'm trying to find there. Hey, there's my Discord window right now. I am in the house, Andy Calloway. Thank you. And if you want to go and check out the Discord chat, you can head to adafru.it/discord, and you'll get an immediate invite, and then you can join in on the chat. It's a fun place. There's a live broadcast channel where the discussion's happening for this show, and there's a whole bunch of other channels where you can go to get help with things, where you can shoot the breeze about stuff. It's a 24/7 family-friendly maker space kind of hangout. So that's a good place to go and see what's going on. I see someone said Lars has followed me in the house. Weird. I'll have to track him down later, I suppose. And let's see, with that, okay, so unfortunately this was somewhat a last-minute move, so I don't have my normal software up. In fact, I'm using completely different software. This is what I use when I do my MakeCode live stream, so thankfully I was already kind of set up in this space and had something going, but it's a completely different setup than what I do for the workshop show, so things will be a little weird. But if you're watching this show, you probably don't mind when things are a little weird, right? And inside baseball, this is OBS. Normally, this software that I'm broadcasting to you from, normally I use Wirecast, which they're both very effective. Wirecast costs money. OBS is free. Wirecast is great for doing lots of pre-set up scenes and layers and things like that. Galleries and slideshows and the kinds of features that you see PT using, especially on Ask an Engineer or the Ruiz brothers on their show. They use some really in-depth features of Wirecast. I have found OBS is pretty good for the MakeCode live show because I'm mostly broadcasting me and one screen and not flipping around to a lot of setups. But it's got scenes. It can do that kind of stuff. So I'm growing more comfortable with it, which is good because it's nice to have options, right? So, for example, let's see. What do we want to talk about here today? I'm going to, first of all, jump over to... Oh, look. That's already our first weird thing. We're going to do Product of the Week next. Sure, why not? I didn't name things properly, so that was a surprise to me. So, Product of the Week, I'm going to pop open... Let's see. Is this going to... Let's bring this up here. Sure, that works. So there is my product pick of the week. It's the Adafruit Metro M4 Express Airlift Wi-Fi light. I've actually never... I need to ask Lady Ada, what's the light about? I'm not sure if there's going to be a heavy one or what, a dark one. But this is our Metro M4 that has an ESP8266, I think, daughter card or what's the word I'm looking for? It's a helper chip that does the Wi-Fi. So let's see. Let me see if I can read this. What does it say? Is it? Oh gosh, I'm throwing on my glasses. I can't see that at all. ESP32. Okay, yeah. Of course, it's ESP32. That's the new thing. That's what we like now. And that acts as our coprocessor. That was the word I was looking for. That acts as our coprocessor for doing Wi-Fi, which means this is a really good board for doing IoT things. It's also a great, powerful all-purpose board. It can run Arduino. It can run MakeCode. I think we can use MakeCode on it. It can run CircuitPython really blazing fast because it's a robust chip and lots of memory on there. So it's a great overall board. In fact, I'm going to be using it in my project of the week today when we get into that. And eventually I'll be, in the project we're working on today, I'll be adding Wi-Fi stuff to it. So this is a nice all-in-one solution rather than adding on a secondary Wi-Fi processor. This one has it kind of bolted onto the board there. That's that silver thing you see right there. Oh, you can't see my mouse, but there's a big chip there that's in a little silver metal cover, protective cover, and that's the Wi-Fi handling ESP32 in there. So that's my product pick of the week, and that's in stock. You can buy that from Adafruit for $34.95. So that's a very nice all-purpose board. Go check it out, would you? All right, let's see. To hide that, I'll go back to my main cam. Boy, this is going to be weird getting used to. Let's see. Next thing up. How about, yeah, why not? I think we'll jump into the MakeCode Minute. Sure. Things are all kinds of funny orders today. Here we go. Let's see if this works. All right, so let me get this set up before I say the magical words, which starts my timer going for my roughly 2 minutes that I like to do these in. Let's see, I've got a view here that'll work. Okay, sorry the focus is a little tricky on this one. It's quite dark and it's not a great sensor on this webcam I'm using. But what you'll see here is I've got a Circuit Playground Express off on the left, and I've got a ring of NeoPixels on the right here. And so let's get over here where I can zoom in. Okay, so for today's MakeCode Minute, I want to show how you can use a gradient block with an external NeoPixel strip to do interesting color things really easily. Just a couple of blocks are necessary. So first of all, what I'm doing here is I've got an on-start block, and then going over to the light category and NeoPixel, here we can create a new strip, which is going to be an external strip rather than the one built on board. And we can tell it what pin we're using, what data pin we're using, and the default is A1, and how many NeoPixels are in that strip. So I've got one here already, which is on pin A7, so it's plugged into A7 on the Circuit Playground Express that's driving it. It's also plugged into ground and power, and it has 24 pixels. I counted them. I think I got that right. Then I'm setting this strip mode to be RGBW. It just happens to be the type of NeoPixel that has that fourth diode in there for white, as well as RGB. And then I'm setting the strip brightness really pretty dim. Just helps it be seen on the camera here. And then initially I'm setting them all to pink, and you can see here kind of on the reflection on my hand and on the sides of this box it's in, it's easier to see the true color versus straight on. And then if you look in this NeoPixels drop down or category, we have a block here. I've never used it before. I don't know if it's new or I'd never noticed it, but it says set strip gradient from, and then it has two color index choices. So I've put one inside of a button A click input block and one inside of a button B input block. And then you can tell it which strip, if you have multiples, you're using. So I'm picking just the one called strip. And then you can pick from the indexed color choices a gradient that you want to use. So let's use what's on there right now, actually. This is what's built on board. So I'm going to hit my A button, and you'll see it's now running a gradient. This one happens to be from purplish to yellow, or yellow to purplish. And then the B button goes from red to blue. And then you can go in there and customize those to your heart's content. But the nice thing is you get a really sort of sophisticated look. It's doing a bunch of the color math under the hood for you. But you get really nice results. You can gradate to fade out, for example. If we go, let's say, from red to black and put that on the board, we should be able to, once that restarts. Oh, it didn't like that. I don't think that's black. I think that's the brown. All right, let's try that again. All right, there's the black. That's it. Yeah, it was going through some kind of orangey, green, yellowy things to get there. And once that uploads to the board, oh yeah, it doesn't like that one. Okay, let me try. Yeah, I'll leave that where it is because I've probably gone over, and there'll be some creative editing to make that look like maybe everything worked. But that is a way that you can use the very simple gradient block to run from one color to another on your NeoPixels. And that is your MakeCode Minute. Whoops, hey. It's like the show just restarted. Okay, so let's see. The format here, like I said, is going to be a little strange. And what I'm going to do next, actually, is I want to get into the bulk of the project. We'll keep this show sort of short today. Normally my show's a half hour. I've been going a little long lately when I had a lot of content and everything prepared. But today we'll keep it to the sort of regulation half hour or closer to it. So what I'm going to do is adjust what I've got underneath my webcam here. And I'll show you my hardware setup for this on-air matrix display sign that I want to show you today, the project we're going to work on. So let's go to a downshooter view here. And I know this is a bit dark right now. That's going to help with the LEDs. But here I want to show you the physical setup. What I have is the Metro Airlift M4 that I talked about earlier with a shield on top of it. And this shield is you can see right there, Adafruit RGB matrix shield. So this does all of the complicated timing and wire connections out to these RGB matrices. And we have a couple variations on this type of board. We have one for feather, we have some breakout ones. And what's running to it right now? I've got USB over this purple cable so I can code it. And sometimes you can even run that power to the display if you're not throwing all the pixels on with a lot of color at once. Sometimes that's enough. But better yet is you've got a separate power plugged in. So if you look there, that's a power 5 volt that I have. It happens to be a 10 amp, which is way overkill. It's just what I have, but it's a wall wart that's giving us a lot of power to drive those matrix LEDs in the panel. And then this little screw terminal block here is what's sending power out to the board. So the board has a a ribbon cable connector, IDC connector, that's sending all of the data communications to tell which pixels to light up. And then the power is running from that driver board up to this separate ground and power block. So let's flip this over. Oh, and one other thing is I've actually got kind of a temporary solution here to plugging in a switch. So I have a couple of wires running to a switch here that's going to allow me to toggle back and forth between a couple modes. And then let's get this into view here nicely. That's pretty good. You can see it's quite a wide angle webcam that I'm using here, so you'll let me go ahead and zoom it out just a little bit. Hold on. I've got a manual. Oh, that's the widest it's going to go. Okay, I've got a manual zoom and manual focus webcam here that's working pretty well for this. Again, like most LEDs, I don't have a good way to show you the true color of that right now other than putting some LED plastic over top of it. So I'm just going to set that on for a second so you can see a little better what some of the colors are we get with this. But then I might leave it off because I think it's going to put things out of focus. And it does that fun thing. I actually don't know why we notice the scan refresh much more when this LED plastic is in front. It could just be that the blowing out the sensor hides that. Yeah, I guess you can kind of see it a little bit, but it's not as noticeable. So what I'm making here is an on-air sign, and the idea behind this is that it's kind of it's twofold. Someone's saying in the chat, C. Grover said, "Oh, I'm confused. How can we see the off-air sign?" Really good point. We're on air now, so this is a lie. This should be like this. So the idea behind this is actually we've done a few projects over the years at Adafruit for creating live streaming on-air signs, just like a radio station or a television show. This is a sign, a lighted sign that's often out in front of a door to let people know to be quiet if they open the door or not come in at all. And the typical use for these projects, the ways that we've created them in the past, has been it is grabbing some data from an API that tells the device when a particular channel is live. So something like a YouTube channel going live or a Twitch channel going live. Those have APIs or application programming interfaces that give up some data, if you ask for it, that says if the channel is on broadcasting or not. And I'd like to do that to this project because I think it's really cool, and I do broadcast, so it'd be nice to put this outside of my door to the studio here, and maybe another one outside of my workshop. Excuse me. And that way, my family members will know that I'm broadcasting, or I can use it as an indicator where I can see if anyone from Adafruit is broadcasting, because we're all using the same channels. So there's a couple of the uses there that we've had. But I realized right now, given the fact that pretty much everyone is home and broadcasting in video chats a whole lot of the time, and we don't want to interrupt each other. So if you have someone you're living with, spouse, kids, roommates, it would be nice to know, hey, I'm in a video conference call, I'm in a Zoom call or a FaceTime chat or something, don't come knocking. And in those cases, there may not be a really neat, elegant, programmatic way to grab information that is floating around on the internet saying that your kid is in a Zoom call. And that's why I wanted to build this simple one that just has an on-off switch. So you could just simply click that when it's on and click that when it's off, or you could have it go completely blank when you're not on air and only show the red on-air sign when you're broadcasting, and it means don't disturb. It's a do not disturb sign. And so that's kind of the reasoning behind it, and that's what it looks like. And now what I wanted to do is look at the code and talk about a couple of things here that are a little different than some of the other RGB matrix sign projects I've done. So let's find, here we go. So here's a Moo session. Oh, look, you can see my LEDs in my glasses there. Look, you'll see the true color now. Got kind of a yellow and the red there. So let me do a little fixing of some layers here so nothing bad happens. And now I'll find my Moo session. Where did you go? There you are. And okay, yeah, you can even see me clicking on stuff. So there are a few ways that we have to display graphics and text on these displays. And so, for example, the digital demonstration and protest sign I created bitmap graphics that were 64 pixels wide by 32 pixels high, and then those can be displayed. Those bitmaps can be displayed. Oh wow, these glasses need a cleaning. And that makes it nice if you're trying to do some fairly complicated graphics and they're static in the sense that you're not going to update them much. And you could definitely do that with this project. You could create prepared graphics for on-air and off-air and then just do the slideshow. That would be totally valid. But in the interest of learning more about how we can work with these signs, I was thinking about using real text. So you'll see in some of our projects we've used the terminal font, kind of the default font, very simple single stroke font. And that's great because then you can just type in text and it generates the pixel mapping on the fly. But then we also have this sort of in-between ground between the two, which is using a bitmap font. And so a bitmap font, in fact, I might show you a little demonstration inside of a font editing software so you can see what's happening here. But if you think about a font or a typeface on the computer, they tend to be a curve-based description of an outline of a set of letters or glyphs. And they require some significant or non-trivial at least amount of processing power to render those fonts, because they are descriptions, a mathematical description of a thing, which then needs to be turned into plotting of pixels on the screen. And so with a bitmap font, what we do is we sort of stamp down a series of glyphs at a particular size. So we'll geek out a little bit about typeface stuff here for a second. Oh, my Siri thinks I'm talking to her. If you ever studied anything about typography, there are sort of these classes of things. And so at the top of it, we have something called a typeface. So if you think of something like Helvetica, that is a typeface. A font is the typeface at a particular size and sometimes at a particular style. So 24-point bold Helvetica is what's considered a font, whereas Helvetica itself is considered a typeface. None of this matters that much, but pedantic people like to yell about it, and it is actually useful when you're doing what we're doing here. So if we have Helvetica as a typeface, if we have it at a particular size as a font, we can then generate bitmap versions of the glyphs or individual characters of that font, meaning that particular size, because we're stamping them down. So now we can say, okay, I have a collection of bitmap descriptions, which are coordinate points, really, just saying where each pixel goes of that one letter. So if we look at, I'm gonna switch back over to my down shooter again. So if we look at something like this letter R, this is at a particular size. The size here actually happens to be 21, and that is because a glyph may have a descender. So it starts at some height, and then it goes down to what we consider the baseline, but then it can go below it. And so I think I'm using 15 pixels that you see here, but if this were a lowercase j, I think it would be going off the screen right now just because I'm so far down. So the bitmap description of this one at 21 was the size, 21 pixel size font, meaning the height, then has some ratio that was designed to look nice of that width to the height, and it varies depending on the I or the R. They're set at different widths, and they also have certain spacing so they don't cluster right after each other. So there's even in bitmap fonts, there's a notion of kerning, or the distance between the glyphs, the letters. Okay, so if we take a look, why don't we go back to Moo here for a second? So if we take a look at how this works, I'll even zoom in a little bit more here. So the first thing I'm doing, this is all what's running in CircuitPython on the Metro M4 Express airlift here. And what I'm doing is I'm importing some library code to make life a little easier, including this display text.label. That's what allows me to type in words as a string, or characters as a string, and then have them be displayed. And they normally can be displayed just using the terminal font, the built-in simple one. But here you can see I've added a import of the library for the bitmap font. And actually, I don't need that slideshow anymore. I can get rid of that. This code is sort of temporary, so it's not been optimized very much yet. Then I'm setting up my switch, which is how I'm using the physical toggle switch to go between the two modes. Here I'm setting up my display. So this all uses display.io libraries, and we do things like set the panel width and height. So this is a 64 by 32. I'm using that in a couple of places elsewhere, just thought it would be easier, including some line drawing stuff. And we'll talk about line drawing and sort of mapping individual pixels that aren't characters, because that's the other thing I'm doing with some of the graphics on here. There's some specific stuff about which board I'm using, so which pins on that breakout board that talk to the display. And then I start creating these hierarchies of objects that draw. So there's a display group, and then there's a bitmap and a palette, which are showing images and what colors they are. And those images are anything. Bitmap is a little misleading there. It doesn't mean a raster graphic saved on disk necessarily in this case. I've set up a few color choices here that I'm going to use as palette index list items. And then we create the tile grid, which is going to include the different image elements that we're putting on screen. And then I've created a little helper function for myself called draw lines. And so at the very simplest, there's a call here called bitmap, and then a x and y coordinate point starting at 0, 0 in the upper left, and then 64, 32 in the bottom right, and which color from the palette we're using. So you can just type in bitmap 1, 1, and the sort of second pixel, I'll say it's 0, 0. The very first pixel will get lit up with one of those index colors. And all I've done is created a helper function here that allows me to draw a line if I give it a start point and an end point and a height. So I can draw a 4-pixel thick line horizontally, or we can do it vertically in a given color. And then I start using them. So draw a line from 0, so that's the left, to let's see. Let me add a camera view here. This is dangerous, but I want to show the pixels while I'm talking about them. How about we add a, is that considered a display capture? Hold on one second. You know, I'm just going to pop over to it. That'll be safer. So if you look at the line here, this is using that starting at 0, and it goes 10 pixels, and it's 2 pixels high. So that's the first case of this. And then the second one, which is over here on the right, is this draw line from pixel 54 to 10 units or 10 pixels wide, and then it starts at Y and is 2 pixels high. So that's how I'm drawing lines on the sides and bottom and the top. And then I did kind of a similar thing for these kind of wings graphics, as I'm calling them. So if you look at these, I wanted these sort of aerospace Art Deco style, streamlined modern style letters to go with this Art Deco font or typeface. So to create these, what did I do? Let's look. Whoa, not that, this. Oh yeah, so I created a thing called Draw Wings, and this is kind of brute force right now. There's obviously this could be optimized, but it's just drawing in those lines to make the 3 little sections on left and right. And the only reason I wrapped that up in a function is that I wanted to call it in different colors. So when I switch the 2 modes, I'm just redrawing those pixels in yellow or red, or I think I called it gold and red. So I wanted a function that called those so it would be easy, and it takes an argument of a palette color. Then I'm setting up my font. So here is where I create a variable called deco font, and it uses the bitmap font load font command, and then I tell it the name of the bitmap font file that's on the disk. So I exported that and put it on disk. And actually, this is a good time to, let me see if I can jump over here real quick. This could go real weird. Let's see, but maybe not. So this is a X Windows based piece of software I'm going to show you. Let's see, where is my, maybe that, yeah. Okay, so this is called Font Forge. It's an open source piece of software. And you can see here I've imported in a, I think not a true type font, but maybe an open type font And then it's showing me all of the glyphs. I've turned off anti-aliasing, so you'll see that they're kind of jaggy, but that's where the real sort of pixel positions are going to be. And then if I want to look at what the 21 pixel high, starting from here going up, bitmap version of that outline is going to look like, this is what it's going to do. So it's, you have to, there are some sacrifices involved when you turn an outline font into a very small bitmap font. So that's where things are going to be. And you could actually go in here and tune this if you wanted. If you didn't like the way it looked and you wanted to nudge things a little rounder looking, let's say, for that R. And then I think we can zoom out. Not sure. Yeah. And then you can turn off things like the outline and the guide, and then you can see if you like how that change will be. Best way to see it, though, is right on the board. So after we tune them, or even if we're not going to tune them at all and we're just going to open this up, we then create bitmap strikes, and I'll create one that's of the right size. So I said 21 pixels. And that's for, you can pick like just a subset. If you're only going to do numbers, you could pick these. You don't necessarily need a lot of this crazy stuff down here if you're not going to use it, and it makes it smaller. And then we regenerate the bitmap glyphs for those selected ones, and that'll incorporate any changes you make editing. And then we'll ultimately go to generate fonts, and here's where we say what size. This is actually 42 right now. Oh, no, I have one on there that's 42. So yeah, this is 21. And when that gets saved, you can then put it on the disk of the CircuitPython drive, which is our MakeCode right here is accessing the root of that drive where it says Balota text bold 21. Then I am just setting some positions because I have that word on and off, which will happen on the same line but at different positions. So I have a couple of different positions that are offset from the left of the board, and the Y positions, which will stay consistent, as well as I think I could grab the palette colors for this, but I had made some colors right here. And then I'm telling it which lines to create as sort of children in the hierarchy of the groups that are displayed. Those get appended to the group, and then they don't actually draw until we start up. So right now I'm checking, this is the main loop of the program, I'm checking the mode state, which state the switch was on when we turned it on, and then it immediately displays the right on or off. And then after that, if I go changing, and again, this has problems that I need to fix. It works, but it's I think it's constantly looping. But this allows me to flip the switch, and then it will take the text and change it from on to off, and adjust the position and change the color. And then finally, it draws the wings in either color palette 1 or color palette item 3. And then we show the group and change the state of the button so that we can flip it on and off. So if we go back to the webcam down shooter, that's what allows that to happen. And I'm excited about doing things this way because rather than a bitmap, like I said, we can adjust things to our heart's content, and things can be adjusted in code. So if we wanted to scroll something on or off, or have the typed values say something about your YouTube subscriber count when you're on air, that type of thing. Now we have a nice typeface set up that can be used, or a font, a bitmap font that we can use to update things a little more real time versus bitmap graphics. And so let's see. I think that that covers everything. I'm going to take a look over in the I'll leave this up because we are on air. I'll take a look over in the Discord chat and YouTube chat. Hello, hello. Lars is behind me on my right. Oh, he's over there he's playing video games, I think. I can go back to the main cam and you can enjoy. Hey, Lars. Let's see. Oh, someone asked, Makalaka asked said the song wants to be heard. I know, I kept clicking on What's the board? So this is, actually, I've left the label on this one because I was getting confused about which boards these are. I think this is the 5mm pitch version of the 64 by 32. Yeah, 5mm pitch, 6432. In fact, I'll bring that up right here since people are curious. Let's see, what's his easiest way is 2277 is the product ID. 2277. And I'll switch over to that view. Where's that? So this is the 64 by 32 RGB LED matrix, 5mm pitch. So these come in, I think, 3 sizes that we sell. There's a 4, 5, and 6mm pitch version. I think that's right. And it just determines how big or small they are. Also how dense. I have this little guy here, I think, is the 4mm, and it's a nice dense board, but it's at the sacrifice of not being quite so big. So, and let's see, any other questions? No, and you know what? Since I've got this displayed here, I will show you the RGB matrix shield. If I can find it. No, what's your product number? Why isn't the search yielding? Adafruit RGB matrix shield. No, Arduino doesn't do it. I'm gonna take the board off so I can look on the bottom of it and see its number. Oh, it's not. There's no number there. Oh, I will show you one thing though. Let me turn the webcam back on the downshooter here. If you look closely, if I can focus, you'll see that I had a version 1 board, and we sell the version 2 now, but on this version 1 board there was something I needed to bodge and jump here, so I had to jump something and cut a trace to get that to work. I also left this on when I unplugged it, which is a bad idea, so let me plug this back in and then power it on. And you'll see it will actually work with just USB in this case. There's our little boot up. It gives us our CircuitPython Blinka snake while it's starting up here. And then we're on air. All right. Well, I think that does it for today. We've gone just a little longer than the actual regulation half hour, but hopefully no one will mind. And thank you for putting up with the sui generis show here today. I had a very last-minute change to doing it from the studio here instead of my workshop. And that is all I've got. So thank you so much. Thanks for coming and hanging out. And nice to see everyone in the chat over on YouTube and in Discord. And if you do know, actually, if anyone has the answers to my questions, aha, the image was what tripped me up. It's product 2601. Was I looking at it? Yeah, I sure was. Aha, there it is. Yeah, thank you, Toddbot. It was this one right here the whole time, but I, for some reason, was looking for a board, not a picture of a display. So that's it. It's a $6 shield that makes life a lot easier for plugging in your matrix display for either an Arduino of any kind, Uno-shaped sized one, or any of the Metro boards. You probably use the Grand Central. Those will all fit that. So thank you for finding that there. All right, and with that, I'm going to say goodbye. So thank you, everyone, and I will see you next time. Bye-bye.